Alright, so another problem from the book, just in terms of properties of logs. This is coming from page 372, I believe it's number 84. Their instructions are to simplify this logarithm. So we really want to simplify that. Now, what does it mean to simplify? I guess what's not simple about it, what looks weird. I guess to me, I like fractions, but a lot of us prefer to write things without fractions. I'm not probably going to find the value of this by hand. I would be typing into a calculator. So I'm thinking like maybe I want to get rid of the fraction. I definitely want to make it in a form that I can type it into the calculator nice and quickly if I wanted. I think that's where I'm going to go. I'm going to go for that idea of, can we put this into a form that I can type in very, very easily and very, very quickly in a calculator? Because that's how we're going to evaluate this. We're not going to evaluate this, like I said, by hand. So I really want to make this into a nice, convenient form to evaluate, to find the value of. So when I'm looking in here, I notice that I have this division. My input into my log is really comprised of two different things that were being divided. And if I think about that, those exponential expressions, that means, because that's what this stuff is, it's like an exponential expression or powers. We really have two exponential expressions that were being divided, which means if they had a common base, we would have subtracted their exponents, which means I can actually split this as to two different logs that are being subtracted because, logs, remember, are exponents, essentially. And so if we do that, let's go for the alternating colors coding strategy. I can really write this as the natural log of 6. So subtract the natural log of e squared. Okay, not so bad. Now when we're looking at this, it does look maybe a little simpler, but at the same point in time, I have two logs. This is really making me think of something. Now, I want you to keep in mind, a little quick lesson on logs. We have the natural log of 6 here. I'm just going to choose to write that natural log a little bit differently. I'm going to write it as natural log base natural number, log base e. So I'm going to write that as log base e of e squared. Now, keep in mind what a log asks. What's the exponent on e that makes e squared? What's the exponent on e that makes e to the second? That answer is 2. Logs are really the inverse of an exponential, and so this log is canceling out the exponential and leaving us just with a 2. So really this whole thing becomes the natural log of 6 subtract 2. Now I want to make sure, I want to stress this, and this is the answer that's in the back of the book, by the way, but this is the natural log of 6, not the natural log of 6 minus 2. So it's the natural log of 6 and then subtract 2. The only input into the natural log is the 6. The 2 is separate. So I could really write this if I wanted. Maybe I just wanted to highlight that as negative 2 plus the natural log of 6. I could always write it that way too if I want to see it, just to make sure I'm clear on that. But anyway, hope this helps. Properties of logs, go us.